If y equals sine inverse cos x, show that dy dx is equal to k, where k is a constant. So what we're going to do is use our chain rule formula, which is also known as the outside-inside rule. And in words, when we're using a trig function, we differentiate the inverse trig function, we keep the value, so that's the outside, and we multiply that by the derivative of the value. So we differentiate the value, so that's the inside. So cos x can be seen to be cos x over 1, because anything can go over 1. So therefore, we're going to use this formula from our formula book. So if f of x is sine inverse x over a, where in this case the a is 1, then the derivative, f prime x, is 1 over root a squared, so that'll be 1 squared, minus x squared. So we have dy dx equals 1 over root 1 minus cos x to be squared. So the a is 1, so a squared is going to be 1 squared, which is just 1. And the minus x squared is going to be whatever the angle was. So it's minus cos x to be squared. So the blue section is where we've differentiated the inverse trig function. And the yellow part, cos x, is where we've kept the value. We've kept the angle cos x. And we multiply that by the derivative of the value. So the derivative of cos x. And the derivative of cos x is minus sine x. So you get that from your formula book. Then we multiply. So minus sine x can be written as minus sine x over 1. So top by top, bottom by bottom. 1 times minus sine x is minus sine x. And root 1 minus cos x to be squared, multiplied by 1, is root 1 minus cos squared x. So we have dy dx equals minus sine x over root 1 minus cos squared x. And then using our trig identity from page 13 of our formula book, which states that cos squared a plus sine squared a is equal to 1, well, we can rewrite this and bring the cos squared a over the equal sign to become minus cos squared a. So we have sine squared a equals 1 minus cos squared a. And then we can bring the squared over the equal sign to become square root. So we get the sine a on its own. We're solving for sine a. So we have sine a equals root 1 minus cos squared a. So what we can do is rewrite the root 1 minus cos squared x as sine x. So instead of sine a, we have sine x, and instead of root 1 minus cos squared a, we have root 1 minus cos squared x. And the top stays the same, so minus sine x stays as minus sine x. So we rewrite root 1 minus cos squared x as sine x, and we got that from our trig identity. We just rearranged it to solve for sine a, but in this case we're using sine x. And then sine x will cancel with sine x, leaving us with minus 1. So we do indeed end up with a constant. And this is page 13 of our formula book, our trigonometry section. And in the top right corner, you will see our identity that we used. So cos squared a plus sine squared a is equal to 1. This is a trigonometric identity. So what we did with this was we solved for sine a. So we brought the cos squared a over the equal sign. It became minus cos squared a. And then we brought the squared over the equal sign. It became square root. So we ended up solving for sine a, but we actually used sine x instead of sine a.